This question is asked in Gate 22 of Computer Science. This is from digital subjects or might be computer organization, you may say, and from floating point representation concept. Okay, the question here is consider three floating numbers A, B, and C stored in register RA, RB, and RC respectively as per IEEE 754 single precision floating point format. The 32-bit content stored in these registers in hexadecimal forms are as follows. Like this is your content of register A, register B, and register C. Which one of the following is false? So these are the options we have to find which are false. So first thing is, the first thing that we should know is in IEEE 754 single precision format. So what are the various role of the various bits? Okay, so in IEEE 754 single precision format. So let me show you the pattern of these 32 bits. So this is your sign bit. This is 1 bit. Okay. If it is 0, then the number is positive. If it is 1, the number is negative. Then we have 8 bits. And these 8 bits are meant for, this is called biased exponent. Okay, this is 8 bit. And remaining 23 bits. So this is called mantissa. So sign bit symbolic notation I'm using S, biased exponent I'm using symbol notation B, and mantissa I'm using the symbol notation M. Okay. So if you have numbers like this in the binary format 32 bits, if you want to find its decimal value, okay. So this is a very standard, well-known formula or pattern, you may say, whatever. Its decimal value is given by -1 to the power sign bit S multiplied by 1.m for mantissa into 2 raised to power biased exponent minus bias. Biased exponent minus bias. And the bias value in the single precision format is 127. So in general, so let me make this bias value, it is 127. This is a standard value. In the single precision format, it is 127, the bias value. So there are three numbers. Those are the content of the register A, B, C. So let's start with RA. So register A content, if you see, how much is the content? That is C14 and then followed by 5 zeros. Note carefully, like these are in hexadecimal notation. If I write it binary pattern, C stand for A, B, C, 10, 11, 12. 12 is 1, 1, double zeros. Then 1, 0, 1, 0, 0, 0, 1. Then 4, 0, 1, double 0. Then 0. Then again 0. Again 0. How many 0 are there? 5 0, right? 1, 2, 3, 4, and this is 5. So this is your C, this is your 1, this is your 4, 0, 0, 0, 0, 0. I have just written this binary pattern. So if I ask you what is the decimal value, so let's say this is DV and this is A, okay, the content of this one, -1 to the power sign bit. What is the sign bit? This is your sign bit, okay, S equals to 1 here, -1 to the power 1 into 1, then mantissa. What is the mantissa? By the way, so let us first bifurcate it. So first bit is gone, then remaining 8 bit is for biased exponent. So here 3, 4. So this is your okay. So this is your biased exponent. Then if you write the format, so this is this is 1 point. It will be 1, right? Because you can see this is your sign bit. This is your biased exponent, and then this is what is your mantissa. So I have 1, so I'm writing here 1.1. Okay, this multiplied by 2 to the power biased exponent. So if I ask you what is the decimal equivalent of this biased exponent, like 1,000,000, then 0010. If you find it, so that happens to be 130. So this is 2 to the power 130 minus 127. So if you simplify this, -1 to the power 1 is -1, and then this is 1.1 into 2 to the power 3. So this is how much? This is minus of 1100, and minus of 1100 means in decimal format it is minus of 12. So we got the value of A is minus 12. Same story we have to repeat for B and C as well. So if I ask you what is the content of RB, which is given how much? 421 followed by 50. 421 followed by 5 zeros. 4 stand for 0100, 2 stand for 0010, then 10001, then your 5 number of 0. Okay, so this is your sign bit. Then your biased exponent is these 8 bits are biased exponent, and remaining this is what your mantissa. So if I ask you what is the decimal value of D, so this happens to be minus 1 to the power sign bit is 0 here, minus 1 to the power 0 multiplied by 1 dot, so 001. I'll be continuing like this till I get these ones 0, so we'll stop there, right? So it is 1.001 multiplied by 2 to the power, this is how much you get, this is the biased exponent value. So again you find the decimal equivalent of this pattern. So this happens to be 132 minus of 127. So minus 1 for 0 is 1, 1.1 into 1.001 into 2 to the power 5. So if you put 50 here, this is how much? 100,100, right? So this is in binary pattern, and if you find its decimal equivalent, so this decimal equivalent happens to be 36. So we got the value of B is plus 36. And then finally, what is the content of C register? C register, if you see, it is 414 followed by 5 zeros. 414 followed by 5 zeros. 4 stand for 0100, 1 stand for 0001, 4 stand for 0100, then 5 zeros. 3, 4, and this is your 5. Again, if you see, this is your sign bit, and 34718. This is your your biased exponent, and this is your mantissa. So if I ask you what is this value, decimal value of C, DVC, so this happens to be minus 1 to the power sign bit is 0 into 1.1, okay, then into 2 to the power biased exponent. Again, if you find this, what is the value of this biased exponent decimal form, that is again 130. This is 130 minus 127. If you simplify this, this is 1 into 1.1 into 2 raised to power 3. So this is 1, okay, so 3 zeros means what it will be? It will be 1100. So this is coming 12, of course, plus 12. So this way we found the value of C as well. So that is your plus 12. So we got this value A, B and C. So now let us see which are false. A plus C equal to 0, correct or wrong? A plus C, A is minus 12, C is plus 12. So the sum of that is 0. So this is true. C is equals to A plus B. So C is equals to A plus B. C is 12. What is A plus B? 36 minus 12 is 24. So this is not correct. B is equal to 3C. So 36 equals to 3 into 12. Yes, this is correct. B minus C is greater than 0. So B minus C, B is 36. C is 12. 36 minus 12, 24. 24 is greater than 0. Yes, this is also true. But what is the question? Which one of this is false? So false we have to select. That will be the right option. So in this case it is B. Right? So B is the right answer for this. This is again like to answer this, somebody should know only how to find the decimal value of the IEEE 754 format. So if you do that, then you can get this value. You can get the corresponding option. So the answer is option B for this. This question is asked in GATE 22 of CS. This is from digital subjects and from number system topic. The question is, let R1 and R2 be two 4-bit registers that store numbers in 2's complement form. For the operation R1 plus R2, which one of the following value R2 gives an arithmetic overflow? So, although there are many 2-3 approaches actually, right, to get the answer, but one of the simple approaches. So, in each case, we'll find C in XOR with C out. Okay, if this is coming 1, then yes, overflow present, and if this is coming 0, then no overflow. Okay, so let's start with option A. Option A is 1011 should be added with 1110, right? 101110, and this is 1110, this is 1111, and there is a carry out also 1. So in this case, this is your C in, I mean, which is carry to the MSB bit, and carry out of the result is basically C out. So this is your C in, and this is your C out. So in this case, C in XOR with C out, and both value are 1. 1 XOR with 1, that is coming 0. If there is 0, then there is no overflow, right? So in first case, we will not have any overflow. So this is not the right answer. We have to pick which is having overflow. So option A is definitely wrong. Now let us see option B. If I go with B, A is 1100, and I mean the second register value is 1010. So 0 0 0 0 1 1 1 0 1 1 1 0, and this is 1. And so basically in this case, so there is no carry here, right? So C in value is 0. C in value is 0, and C out value is 1. So in this case, if you see what is C in XOR with C out, that is 0 XOR with 1, that is happening to be 1. So 1 means overflow is present. So this will be the right answer actually, because in this case we are getting, for your understanding purpose, you may verify C and D as well. C, if you see 0 0 1 1 0 1 0 0. So 1 1 1 and 0. You can see here C out is 0. So we are not getting any carry from this. So C out is basically 0. And to this also there is no carry coming from the previous bit. So C in is also 0. So C in XOR with C out is basically 0 XOR 0 is 0. So 0 XOR 0 is 0 means there is no overflow. In C also there is no overflow. And if you want, you may check D as well. D, if you check 1 0 0 1 1 1 1 1 1 1 0 carries 1 1 1 0 carries 1 1 1 0 carries 1 1 1 1 and carries 1. So you can see this is your C out and this is your C in. So C in and C out are equal. 1 XOR 1 is 0. 0 means again no overflow. So in this case also you don't get overflow. So only thing is in option B we are getting overflow. That's the right answer. This is one of the way. Other way, if you want, you can get the decimal equivalent and you can verify the result in decimal form. So which of the desired results will be fitted in 4-bit forms and which will not be in 4-bit forms. There is also one more way. Anyway, the answer is option B.